All right, welcome to round 2 of Science and Math for HRAC. In this video, I'm going to talk about temperature, mostly conversions, a little bit of the background. And we are going to have a lot of words on these first few slides before we get into the math part. So I want to go back and talk about heat versus temperature. So heat is a kind of energy, and it's a measure of energy, and it's a measure of moving energy in an object. So the object matters, the size of the object matters. And when we say size, we mean the mass of the object matters. So you think about moving energy in matter, you're thinking about the particles that can vibrate in a solid, move around much more freely in a liquid, and go all over the place in a gas, just like you learned in Sci 8510. When we speak about temperature, we are measuring the average kinetic energy, the average moving energy of an object. So this is going to tell you how hot or cold the object feels, and the mass does not matter for the temperature. It's kind of a fine point, but hopefully it'll become clearer. When temperature scales were first developed, they were originally developed relative to a known. So when we started making Celsius, the metric relative temperature scale, they kind of set 0 as the freezing point of water, and we had everything else relative to that. So you can have temperatures above 0, which are going to be positive, and temperatures below 0 that are going to be negative. Fahrenheit, same thing. The imperial or US customary relative measure of temperatures, they had a brine that was 0 degrees Fahrenheit. I've heard a rumor about the temperature of a horse, but I don't think it's true. So Celsius and Fahrenheit are our relative scales. They have a corresponding absolute scale. So 1 degree Celsius, if you change by 1 degree Celsius, it's the same as changing by 1 Kelvin. Notice it's the only one without a degree symbol. It's just that Kelvin starts at absolute 0, as does Rankine, the imperial equivalent of Fahrenheit. So you can never have a negative value. These were used in our calculations for gas laws, and we use them more in science calculations, but we definitely need to be able to convert back and forth between these. So just to look at a slide I've yoinked that will kind of show us the key points on each scale. We have the freezing point of water here at 0 degrees Celsius, which corresponds to 32 degrees Fahrenheit. Make sure you know this. And then you see that it's about 273. We're going to drop the 0.15 Kelvin. So we know that to convert between Celsius and Kelvin already, the number 273 comes in play, and also corresponds to 491.6 Rankine. The formulas to convert between relative and absolute temperature scales are pretty straightforward, as long as you're not going cross systems like metric to imperial and back. So here we go. We've got 4 formulas and 4 questions that correspond. So if I want to find a temperature, 35 degrees Celsius in Kelvin, I'm looking for a formula that is solving for Kelvin and can have a given value of Celsius. So it's pretty straightforward. We're going to do Kelvin is equal to the temperature in Celsius plus that 273. And that just is because 0 degrees Celsius is 273 Kelvin. That's where that's coming from. So we have 308 Kelvin, the only temperature that doesn't have the degree symbol in it. Looking at number 2, we're looking for an absolute temperature. We're given Fahrenheit. So given Fahrenheit, that means the temperature we're looking for is Rankine. Degrees Rankine is going to be equal to the temperature in Fahrenheit. Don't drop the negatives. Plus 460 equals 70 degrees Rankine. Number 3, we have Kelvin. Maybe I'll switch colors here, and we're looking for Celsius. So we have Kelvin, we're looking for Celsius. The formula just kind of flips around. We're going to subtract 273 instead of adding 114 minus 273 I would expect a negative number because 114, you know that 0 Celsius is 273 Kelvin, so we haven't made it, so it's fine if Celsius is negative, and it's nice and negative this time, negative 159 degrees Celsius. And finally, we have Rankine, and we're looking for Fahrenheit in number 4, so our formula is to find our temperature in Fahrenheit. We do 489, our temperature in Rankine, and we subtract 460 equals 29 degrees Fahrenheit, so slightly below freezing. The formulas you most commonly will use, and you certainly want to know and understand, is to be able to jump back and forth between imperial and metric on the relative scale, so between Celsius and Fahrenheit. And just before we get into the math, let's look at these formulas. These 5/9 and this 9/5, where does it come from? Well, if you boil and you freeze, you know that you have between 0 and 100 Celsius, and you have between 32 and 212 Fahrenheit, and the difference here is 100 degrees Celsius and 180 degrees Fahrenheit. And if you looked at 100 over 1 or 180 over 100 either way, and went ahead and reduced that fraction, you'd end up with 9/5. If we flipped it, you'd end up with 5/9. So it's really just this 5/9, 9/5 is how to get back and forth between Celsius and Fahrenheit. And then we pin it, this plus 32 and this minus 32, pin it to the fact that 0 degrees Celsius is 32 degrees Fahrenheit. All right, I'm going to erase all that. And now let's look at the pitfall formula. So you really need to respect order of operations to get this right. So when we look at the Celsius formula to find Celsius, we see brackets. So this math must happen before multiplication by 5 and division by 9. And because of those brackets, and when we look at the how to find Fahrenheit formula, this math must happen before you add 32. So that's the number one place people get tripped up. So let's do it. Looking at number 1, we have a temperature of 68 degrees Fahrenheit, and we want to convert that to a specific temperature in Celsius. So we set it up. Degrees Celsius is 5 divided by 9 times 68 minus 32. My next step is to do the math in the bracket. So I have 5 divided by 9 times 68 minus 32 is 36. Here you can do 5 divided by 9 times 36, or I'm just going to change it into 5 times 36, because if you have a whole number, remember it's like a fraction over 1. 5 times 36 is 180, and I still have to divide it by 9. And then finally, 180 divided by 9 is going to get me 20 degrees Celsius. That's my answer. Now let's look at going from Celsius to Fahrenheit. I want to find Fahrenheit, so I set up my formula. 9/5. Don't drop the negative. Okay, here we go. So I'm going to do 9 times negative 15 and then divide it by 5. And that's going to take me to a number negative 27. 9 times negative 15 divided by 5. So I did it all at once. And I still have that plus, oops, I forgot to write the plus 32 on the end of that formula. Whoops. There we go. Negative 27 plus 32, and that is going to take me all the way to 5 degrees Fahrenheit. My Pepto-Bismol Smart Art here, just kind of telling you the process if you need to get to, say, Fahrenheit from Kelvin, or to Celsius from Rankine, or even from Kelvin to Rankine, although there's a faster way to do that one. Let's break it down. So you might have a two-step conversion, because the place you want to cross, we have a conversion, say Celsius, Fahrenheit, and back, but we don't have this conversion. Or do we have that conversion? So we're going to have to do 2 steps in order to find that new temperature. So let's use our little diagram to do some math here. I'm going to start with number 1. So I want to go from Rankine to Fahrenheit to Celsius. So step 1, we're going to take 130 degrees Rankine and change it into degrees Fahrenheit. So I see that my formula to find degrees Fahrenheit is to take the temperature in Rankine and subtract 460. Don't drop negatives. Trust your calculator. And we're going to get negative 330 degrees Fahrenheit. Next, I'm going to take that temperature in Fahrenheit, just give her a little highlight, and I'm going to convert it into Celsius. So degrees Celsius from Fahrenheit is 5/9, negative 330 minus 32. So just taking an extra step to make sure we got that order of operations down. 5/9 multiplied by negative 362. So watch your math when you're working with two negatives. And if we do that multiplication, we're going to get about negative 201 degrees Celsius, which is our answer. For number 2, we're going all the way from Kelvin through Celsius, through Fahrenheit, and up to Rankine. And then we'll make a note of something. So to get my Celsius from Kelvin, Celsius is 295, the Kelvin temperature, minus 273, which is going to give me 22 degrees Celsius. To make Fahrenheit from Celsius, I'm going to do the 9/5 multiplied by the temperature first, then add the 32, and that's going to give me, I'll keep a decimal place, 71.6 degrees Fahrenheit. And to make Rankine, I'm going to go take my Fahrenheit temperature, 71.6, and add that 460 to create 531.6 degrees Rankine. Now, is there a faster way to do that? Kelvin to Rankine and Rankine to Kelvin shouldn't involve this pinner, right? This 32 degrees, because you don't, they're both absolute. They're both, starting from 0 at the same temperature at absolute 0. So just a thing to note, if I wanted to find Rankine from Kelvin, I know that ratio of degrees, imperial to degrees metric is this. So if I take 9 times the temperature in Kelvin, divide by 5, I'm going to make Rankine. Likewise, to make Kelvin from Rankine directly, 5 divided by 9 times the temperature in Rankine. So just so you know. So let's take a look at this question, because this is tricky and people tend to mess this up. So here I'm not converting a specific temperature. I'm converting a change in temperature. So the rule is, if you're going to do that, you don't find the difference between the two. You don't take 90 degrees Fahrenheit and convert that using your Celsius and Fahrenheit formulas. Okay, you have to, in theory, convert both temperatures to Celsius, then find the difference between your two Celsius temperatures. So let's take a look at that. It's a bit long, but here we go. First, I'll find my hot temperature in degrees Celsius. So we're going to take 5/9 and multiply it by 170 minus 32 in brackets. And I'm not going to show you the math because we've already looked at that a couple times. I'm just going to be like, look what I did in my head. Magical. And then I'm going to convert, I'll give it a little subscript. Convert the lower temperature, 80 minus 32. And if I do all that math, I will get 26.7 degrees Celsius. So the change in temperature will be the difference between the two, which is going to be a 50-degree change in temperature. Just to show you it wouldn't work the other way, if you tried, I'm going to write no, so you know not to do it if you're just looking at the slides. So if I went 170 minus 80 equals 90 degrees, and that's in Fahrenheit, and then tried to convert a change to a point, basically, which you can't do, and used it in the formula just to show it doesn't work, you would get 34.4 degrees Celsius, which is not right. Let's give that a big red X and a lot of highlights on that no. So what's happening is it's kind of like our relative temperature, our absolute temperature conversions, because we aren't pinned down. It's just saying, the conversion between a range of Fahrenheit and Celsius is just that 5/9 or that 9/5 to relate to the 180 degrees versus 100 degrees Fahrenheit versus Celsius. So we have a simpler way of doing it. If you want to convert a change in temperature or a difference in temperature, you can. If you're going to make Fahrenheit a change in Fahrenheit, and you are going to multiply by 9/5. And if you want to make a change in Celsius from Fahrenheit, you are going to multiply by 5/9. Either method works. You can go through all the steps, or you can just do the cheater. Just make sure you don't do that. Okay, and finally, what's a 25 Celsius temperature change equivalent to in Fahrenheit? Fahrenheit equals 9. And maybe we can be a little lazy and use some fraction math so I don't have to get my calculator. Do whatever floats your boat. And that's going to give me 45 degrees Fahrenheit. And you can always double check. If you use the wrong fraction, Fahrenheit should always be higher than Celsius. So that's it for the temperature video. What I want you to take away from it is that you know the 4 scales, you know how to convert between a temperature, a specific temperature between the 4 scales, you know how to convert a difference in temperature or a change in temperature, and make sure you know those boiling and freezing points too.